This is the 2011 Science Practical Exam. We are given solid Q, which we're gonna have to transfer to the hard glass test tube. We need to transfer 1/3. So you just need to estimate the amount. We're gonna heat, so we need to get ready the Bunsen burner. And then if we read on, we realize that we need to test for any gases evolved using red and blue litmus paper. So we need to get ready the litmus first. And to get rid of the litmus, it means that you need to dampen them, both the red and blue litmus with deionized water. So it's important to read the paper, read the instructions, plan ahead before you start doing. So now we will open the air hole for a strong flame. While we are busy getting ready the litmus, we also want to pay attention to the changes that are happening inside the test tube. You will have to pay attention to the solid that's in the tube. So that's the red and blue litmus test. The damp red litmus paper has turned blue, and then we will see what will happen to the damp blue litmus paper. We see water droplets at the sides of the test tube as well. So you need to pay attention to all the changes happening to your litmus, to the solid that's in the tube, everything, all of it you should take note of and remember to write down in your scripts. Since my blue litmus paper turned red, it means that an acidic gas was given off. So now I test the gas with the potassium manganate solution. The purple potassium manganate solution I put on a piece of filter paper, and I see if the acidic gas will go on to cause the purple potassium manganate to become colorless, so that my filter paper becomes white again. If it happens, then I know that the acidic gas that was given out was sulfur dioxide. And so we will see the purple color, potassium manganate decolorized, so you get like a brown color form, and that is a positive test. If I continue to heat and produce more gas, the entire piece of filter paper will become white again. So the purple potassium manganate was decolorized. That was a positive test for sulfur dioxide. Next, we go on to part B, where we need to transfer the remainder of solid Q. So whatever that is left, we put into a large test tube, and then now the instruction says half fill this test tube with deionized water. So we fill it to half. We are supposed to shake and invert the tube until all has dissolved to produce a solution. Since the question called it a solution, we expect that all the Q would dissolve. When all the solute dissolve, this is when we get the solution. So now this is we need to prepare our solution Q to be used in part C and D, part B, C and D. So this is solution Q. We continue with part B. We need to place 3 cubic centimeters of solution Q in a clean test tube. To this solution, we add 3 or 4 pieces of magnesium ribbon. we need to bear in mind magnesium ribbon is, or rather magnesium is a reactive metal, reactive enough to react with cold water. So that's magnesium ribbon. So I expect the reactive metal magnesium to react with the solution tube. So as I add the magnesium ribbon into the solution, I see bubbles. So that's within my expectations. That's what I expect to see. And then now, since there's bubbles, that means that a gas is given off. Then, since if a gas is given off, I'm supposed to test for its identity. Since it's a metal that I added, then I would test for the presence of, for the production of hydrogen gas using a lighted splint. The reaction of magnesium with cold water while it works is rather slow. So what I'm doing is I'm heating the solution a little bit to generate more bubbles, to generate more of the hydrogen gas, so that I may get a positive pop sound, a positive test for the lighted splint. So I see that my lighted splint extinguishes, but there's no pop sound, but I'm quite certain that hydrogen is still given off, even though I do not get the pop sound. We need to leave this test tube to stand in the rack for a few minutes. So we do see some black solid appearing in the tube. So we leave it in the rack and we will remember to come back to observe it again later at the end. So moving on to part C, we need to place 2 cubic centimeters of solution Q in a test tube, and we will go on to add 2 cubic centimeters of dilute sodium hydroxide. This is the classic QA test, so we are looking for PPT and the color of the PPT. We do see the green PPT appearing. The question did not ask us to add in excess, so we shall not, especially when we are to gently warm the mixture now. Since I added sodium hydroxide and the next step is to warm it, I know that this is a test for the ammonium ion. So I get ready my red litmus paper. As I heat, I test for the production of ammonia gas. So I see bubbles. If I do get the blue litmus the red litmus that turns red, the red litmus that turns blue, that means that ammonia gas was given off. That means ammonium ion was present in the solution. So if the bubbling gets too vigorous, it will move the tube away from the fire, but continue to test for the gas like what I did. So I do get a positive test for red litmus, the damp red litmus that turns blue. Moving on to part D, I put 2 cubic centimeters of solution Q in a test tube, followed by 1 cubic centimeters of hydrochloric acid before I add barium chloride. So always shake to mix after adding any reagent. So I add barium chloride, which is the classic test for sulfate ion. So I need to remember I have a tube from part B that I left to stand in the rack. So now I go back and I observe what's happening inside the tube. You will find some black solid. We will not call it a PPT because it is not. A precipitate is the solid you get if you were to mix 2 aqueous solutions. In this case, we started with a solution, but we added a piece of solid, we added a piece of magnesium in. So this black color solid is strictly a black solid and not a black PPT.